Friends, did you know? From sunrise to sunset, our world is shaped by an amazing field we call engineering. Maybe you think engineering is only for math and science geniuses who build complex buildings or robots. But the truth is, engineering is closer to us than we think. It's the art and science behind almost everything we use, from the simple cell phone you hold, to the bridge we cross, to the clean water we drink. It's the process of thinking, designing and creating to make our lives easier, safer, and more convenient. Think about your morning. The alarm clock that woke you up was made by an electrical engineer. The electricity that powers it flowed from a power plant designed by mechanical and electrical engineers. The water you used for bathing passed through a complex system of pipes and a water treatment facility made by civil and chemical engineers. Even the food you ate for breakfast was processed using machines designed by mechanical engineers. In every action we take, in every corner of our society, there's a trace of an engineer's brilliance and talent. Engineering isn't just about building structures, it's about solving problems for the good of humanity. The word engineer comes from the Latin word ingenium, which means cleverness or talent, and ingeniare, which means to create. So an engineer is a clever creator. They are the problem solvers of our world. They see a need or a problem in the community, for example, a lack of clean water, heavy traffic, or the need for faster communication, and they use their knowledge of science and mathematics to design a solution. They are the ones who think of ways to turn ideas into something real and useful. Their work is a perfect blend of logic and creativity. The beauty of engineering is its endless possibilities. It is constantly changing and evolving with the times and technology. The challenges we face today, such as climate change, pandemics, and urbanization, require new solutions from the next generations of engineers. So, learning about engineering isn't just about learning formulas and theories, it's about preparing to be part of the solution. It's an invitation to young people like you to use your curiosity and creativity to build a better and more stable future for all of us. Come on, let's explore the wonderful world of engineering. In the wide world of engineering, there are 4 branches that are considered classical or main, and they are the foundation for many more specializations. These are civil, mechanical, electrical, and chemical engineering. Let's think of them as the 4 pillars that support modern civilization. Each one has its own focus and unique contribution, but often they work together to create something bigger and more meaningful. Understanding these main branches is the first step to seeing the breadth and depth of this profession. They are the original problem solvers that paved the way for the modern technologies we enjoy today. First up is civil engineering, probably the oldest branch of engineering. They are the builders of our world. Their scope includes all the large structures we see around us: buildings, bridges, roads, airports, and dams. They are also responsible for systems we don't always see but are important, like water supply and drainage systems. If a project is big, permanent, and serves the public, chances are a civil engineer is behind it. They make sure these structures are strong, safe, and can withstand the test of time and nature. Next is mechanical engineering, the branch focused on movement and energy. Mechanical engineers design, build, and maintain all kinds of machines, from the smallest watch part to the largest airplane engine. If something has a moving part, it's likely made by a mechanical engineer. They are behind cars, air conditioning systems, elevators, and robots in factories. Their job is to make sure machines work efficiently, save energy, and are reliable. They bring life and power to things around us. The third pillar is electrical engineering, which brings light and power to our world. Their work centers on electricity, electronics, and electromagnetism. They are responsible for generating electricity in power plants and delivering it to our homes and industries. They also design all electronic gadgets, televisions, computers, and smartphones. From tiny microchips to large power grids that support entire cities, electrical engineers are the brains behind it. Their innovation made the digital age possible and allowed information to flow quickly around the world. Now, let's dive deeper into one of the most basic branches, civil engineering. They literally shape the landscape of our cities and communities. When we look at the tall skyscrapers reaching for the sky, the long bridges connecting islands, or the wide roads we travel on, we see the result of the hard work and intelligence of civil engineers. Their mission is not just to build, but to design structures that serve people, make our lives easier, and protect us from natural dangers. They are the modern master builders who continue the legacy of the ancients who built pyramids and aqueducts. An important aspect of their work is structural engineering. Here they calculate the forces that can affect a structure such as its weight, wind strength and ground shaking during an earthquake. They need to ensure that every post, every beam and every foundation is strong enough to keep the building or bridge standing and safe. They use advanced computer software to simulate these situations even before construction begins. Public safety is their highest priority, and every decision they make is based on thorough study and scientific principles. Aside from buildings and bridges, civil engineers also play a big role in environmental and water resource engineering. They design water treatment plants to ensure that the water reaching our taps is clean and safe to drink. They also build wastewater treatment facilities to clean dirty water before it is returned to rivers and seas, which helps protect our environment. Their work also includes designing dams for irrigation and power supply, and flood control systems like dikes and canals to protect communities from flooding. In the field of transportation engineering, civil engineers plan and design our roads, highways, train tracks, airports, and ports. They study traffic flow to create more effective transportation systems that will reduce travel time and increase road safety. They look at the needs of a growing population and plan for the future. In every road that opens new opportunities and every bridge that connects dreams, there is a civil engineer who thought, planned, and worked hard to make it possible. If civil engineers build the body of our cities, then mechanical and electrical engineers are the ones who give them life and energy. Let's start with mechanical engineering. Think about a car. The chassis and body might involve civil or structural principles, but the engine that makes it go, the transmission that changes gears, the brakes that stop it, and the air conditioning that cools the inside, all of those are the work of a mechanical engineer. They are the experts in the laws of thermodynamics, fluid mechanics, and motion. Their world revolves around gears, pistons, turbines, and all the mechanisms that create movement. Mechanical engineers are important in almost every industry. In manufacturing, they design robots and assembly lines that quickly and efficiently make products from food to gadgets. In aerospace, they build jet engines and systems that make planes and spacecraft fly. Even in medicine, they help create prosthetic limbs or artificial arms and legs that give new hope to people with disabilities. Their ability to control energy and movement opens the door to endless innovations that improve our quality of life. On the other hand, there's electrical engineering, the masters of electricity. Without them, our modern world would stay dark and quiet. Their main job is the generation, transmission, and distribution of electrical power. They design huge power plants, hydroelectric, coal, or solar, and the complex network of towers and cables called the power grid that delivers electricity to millions of homes and businesses. They make sure we have a steady and enough supply of electricity to power our lights, appliances, and factories. But their work doesn't stop at power systems. Electrical engineers are also the pioneers in the world of electronics and telecommunications. They design the microchips that are the brains of our computers and smartphones. They are behind the satellites, fiber optic cables, and cell towers that allow us to talk, use the internet, and watch TV from anywhere in the world. Every text message you send, every video you watch online was made possible by the systems built by the geniuses in electrical engineering. They connect us to a digital world. Let's now enter the world of things we don't always see with our eyes, the world of molecules and code. This is where chemical engineering and software engineering shine, two branches that, while different, are both crucial for our technology to move forward. Chemical engineers are experts in changing raw materials into useful products. They use their knowledge of chemistry, physics, and biology to design processes and plants that make almost everything we touch. From plastic and medicine to fuel and food. Think about a plastic bottle. It started as crude oil from deep underground. Through a series of chemical processes designed by a chemical engineer, this oil was turned into small plastic pellets, and then shaped into a bottle. It's the same with the medicines we take. They figure out how to make medicines discovered in the lab in large amounts, safely and affordably. They are also responsible for making fertilizers for farming, paints, soaps, and even for cleaning our environment through pollution control. On the other hand, software engineering gives soul to our hardware and gadgets. They are the architects of the digital world. If a computer or smartphone is the body, the software, the apps, operating systems, and websites, is what gives it intelligence and the ability to do different things. Software engineers write detailed instructions or code that tell the computer what it needs to do. From your favorite social media app, to the video game you play, to the system banks use to keep our money safe, All of that is made by software engineers. Their work requires logical thinking, creativity, and attention to detail. They design complex systems that should be easy to use, fast, and secure from hackers. They constantly learn new programming languages and technology to keep up with the fast changes in the digital world. Nowadays, where almost every part of our lives is connected to the internet, the role of software engineers is becoming even more important. They build the digital bridges that connect information, services, and people all over the world. One of the most exciting and newest types of engineering is biomedical engineering. This is where we use engineering ideas to solve problems in medicine and biology. Think of it like a bridge between doctors and engineers. Biomedical engineers work with healthcare pros to create new tech and tools that help find sickness, heal patients, and make people healthier. Their field is a great example of how we can use technology to directly make human lives longer and better. One of the most famous things biomedical engineers do is design and make medical devices. This includes tools you might have seen in hospitals like MRI and X-ray machines. These let doctors see inside the body without needing surgery. They also make pacemakers, which are small devices put in the chest to keep the heart beating normally. And there are dialysis machines that help people with kidney problems, plus modern hearing aids and artificial eyes that bring back hearing and sight. Another amazing part of their work is tissue engineering and regenerative medicine. Here they try to grow new tissues and organs in the lab like skin, bone, or cartilage, using the patient's own cells. The goal is that someday, if someone needs an organ transplant, they won't have to wait for a donor. They can just make a new organ that perfectly matches their body. Even though this still needs a lot of study, its power to save lives is huge. It's like science fiction slowly becoming real. Besides this, biomedical engineers also help develop prosthetic limbs, which are artificial replacements for missing body parts. Modern prosthetics today aren't just simple replacements anymore. Some can even be controlled using signals from the patient's brain or muscles. This gives them the ability to move like a real hand or foot. Their hard work and new ideas give new hope and bring back freedom to people who've had accidents or were born with defects. Biomedical engineering proves that heart and brains can work together to make miracles happen. The true brilliance of engineering isn't just measured by how tall a building is or how fast a computer runs. It's seen in how different parts of it work together to solve real problems and make life better in a community. Let's imagine a situation. A strong typhoon hits a province, causing widespread flooding, damaged homes, and loss of electricity and communication. Here, different kinds of engineers will become heroes. They will come together, each bringing their special knowledge to rebuild the devastated area. First to arrive will be the civil engineers. They will check the damage to roads, bridges, and buildings. They will lead the cleanup of debris and the building of temporary paths so help can reach the affected residents. They will immediately start planning to repair or build stronger structures that can withstand the next disaster. At the same time, environmental engineers, a specialization under civil engineering, will check the water quality to prevent the spread of sickness from dirty floodwaters. While civil engineers work on the ground, electrical engineers will be busy fixing fallen poles and broken power lines. Their priority is to bring back electricity to critical areas like hospitals, evacuation centers, and communication facilities. They will use portable generators while the main power grid is being fixed. Software and telecommunications engineers, on the other hand, will work to bring back cell phone and internet signals, which are very important for communication between rescue teams and people who need help. Meanwhile, mechanical engineers also have an important role. They will fix water pumps to remove floodwaters from homes and roads. They will also make sure that the heavy equipment used in clearing operations like bulldozers and trucks are working well. Even chemical engineers can help by supplying water purification tablets or setting up mobile water treatment systems. In this kind of situation, we can see that engineering is a team sport. The success of one depends on the support and cooperation of everyone. Being an engineer is more than just being good at numbers and formulas. It's a mindset, a way of looking at and solving problems. There are important lessons we can learn from their profession that we can apply in our lives, whether we're engineers or not. The first and most basic is valuing education and lifelong learning. The world of technology changes so fast. A new invention today might be old news tomorrow. That's why engineers never stop learning. They are always reading, training, and updating their knowledge to stay effective and modern. The second lesson is the importance of being critical and creative. Engineers are taught not to just accept things as they are. They ask why and what if. They look at a problem from different angles before thinking of a solution. But logic alone isn't enough. Creativity is also needed. They need to think outside the box to come up with solutions that no one else has thought of yet. Every bridge, every app, every machine started as a creative idea in an engineer's mind. Safety and social responsibility are also invaluable lessons. A small mistake in an engineer's calculation can lead to a huge tragedy. A bridge that collapses, a building that falls down, these have lives attached to them. That's why safety first isn't just a slogan, but a sacred promise for them. Along with this is their responsibility to society and the environment. A truly excellent engineer doesn't just think about how to build a project, but also considers its long-term effect on people and the environment. Finally, engineering teaches the power of teamwork. As we saw in the example of disaster response, no engineer can do everything alone. A complex project needs different talents and perspectives. The civil engineer needs the electrical engineer, who needs the mechanical engineer, who needs the software engineer. They learn to listen to others' ideas, give constructive criticism, and work towards a single goal. Unity amidst diverse knowledge is the key to building truly amazing things. Friends, we've explored and seen the amazing world of engineering. We've seen how civil engineers shape our cities, how mechanical and electrical engineers power our machines and technology, and how chemical, software, and biomedical engineers change our health and digital lives. Engineering isn't just a job, it's a calling. It's a call to use your smarts, creativity, and hard work to be part of the solution to the challenges of our time. It's the power to build, innovate, and leave a positive mark on the world. The lessons that engineering brings, like how important it is to learn, to think critically, to put safety first, to respect nature and the power of teamwork, are guides we can use in any path we take. Not all of us will become licensed engineers, but all of us can be engineers of our own lives and communities. We can use an engineering mindset in our studies, in our school projects, and in how we treat others. We can ask ourselves, how can I make this situation better? How can I help my neighbor? To young people like you, full of dreams and hope, the world of engineering is open. If you like to think, design, tinker with things, or if you have a heart that wants to help society, this profession might be for you. Don't be afraid of math and science. Think of them as tools, like a hammer and nails, that will help you build your ideas. What you need is to be curious, determined, and to want to make a difference. The world needs new heroes, engineers of the future. So the next time you cross a bridge, use a computer, or drink clean water, remember the engineers who worked hard to make it possible, and most importantly, remember that you too have the ability to build and create. Be open to learning, be creative in your thinking, and always aim to help build a better, safer, and more advanced world for everyone. Because the future isn't just waited for, it's designed and built. And who better to be its architects than you young people? Friend, the world is in your hands, did you know that?